Enolates are versatile reactive intermediates which can be obtained from carbonyl compounds, with a hydrogen on the alpha position. And we learned before that carbonyl compounds with an alpha hydrogen are actually acidic. That's because the initial alpha carbanion is stabilized by resonance to give the corresponding enolates. Enolates are very versatile in organic synthesis. They can react with all kinds of electrophiles. We've seen that before, that enolates can react with alkyl halide in substitution reactions. Enolates can react with aldehydes and ketones in nucleophilic addition type reactions to give beta hydroxy carbonyl compounds, and that's the aldol reaction. Enolates can also react with carboxylic acid derivatives such as acid halides, acid anhydrides, or esters in nucleophilic acyl substitution reactions. And of course, the product is 1,3-dicarbonyl compound. That's Gleason reaction. Enolates, as we learned, finally, can react with alpha beta and saturated carbonyl compounds to give 1,5-dicarbonyl compounds, and that's Michael addition type, or conjugate addition specifically, or chemically speaking, or 1,4 addition. Let's summarize the reactions of enolates, the reactions that we learned about thus far. So what we can do is we take a carbonyl compound, a ketone in general, something like that, with an alpha hydrogen. Remember again, this position is very, very important. It's acidic. That's because the conjugate base is stabilized by resonance, and we have talked about that before. So if this carbonyl compound, this ketone, is converted into the corresponding enolate, then an enolate of this type is obtained. So this is the enolate. Now, the enolate, being nucleophilic, can react again with all kinds of electrophiles. If the enolate now reacts, for example, with an alkyl halide or a substrate with a leaving group, it doesn't have to be a halide, of course. It could be a sulfonate like a tosylate, mesylate, or triflate, something like that, a substrate with a leaving group, then the enolate can undergo substitution reaction. It can do substitution reaction on the alkyl halide, for example, to give an alkylated product of this type. If that's R prime, this is R prime. And of course, remember, this is the chemistry of the alpha position. So that's the alpha position. That's the alpha position. So the CH2R prime, of course, comes from the electrophile, if the electrophile is a substrate of this type, such as an alkyl halide. Now, if the enolate is reacted, for example, with an aldehyde or a ketone, of course, we can use an aldehyde to represent aldehydes and ketones in general, then the enolate can do 1,2 addition, as we learned before, and the product is beta hydroxy carbonyl compound. That's alpha, that's beta. If the enolate attacks the aldehyde, or a ketone, we get beta hydroxy carbonyl compound. And of course, this reaction is aldol reaction. So this is the aldol reaction, and of course, the product is beta hydroxy carbonyl compound. If the enolate reacts with a carboxylic acid derivative, such as an acid halide, an acid anhydride, or an ester, then the enolate will do nucleophilic acyl substitution reaction, okay, and the product is a 1,3-dicarbonyl compound. And this is again, that's the alpha carbon. So this reaction, as we learned before, is called Gleason. And of course, the product is 1,3-dicarbonyl compound. Of course, this is beta hydroxy carbonyl compound if the enolate is reacted with an alpha beta unsaturated carbonyl compound followed by H3O plus or the hydronium ion to protonate the intermediate enolate, then the product is a 1,5 dicarbonyl compound. And of course, we can number them again 1, 2, 3, 4, 5. This is a 1,5 dicarbonyl compound, and of course, this is Michael addition. So this is Michael addition, and this product is characteristically 1,5 dicarbonyl compound. So to summarize the chemistry of enolates, an enolate is very versatile, giving its nucleophilic feature. It can react with all kinds of electrophiles. If the enolate reacts with an alkyl halide, for example, or a substrate with a leaving group, then substitution reaction takes place. This is SN2 actually, SN2 type reaction. So the enolate can react with the alkyl halide or the substrate in substitution reaction is SN2 type reaction. If the enolate attacks an aldehyde or a ketone, the reaction is nucleophilic addition reaction. If the enolate attacks an acid, carboxylic acid derivative, the reaction is nucleophilic acyl substitution reaction. If the enolate attacks an alpha beta unsaturated carbonyl compound, the reaction type is actually 1,4 addition, as we learned before. 1,4 addition or conjugate addition. And the products of these name reactions, so this is the substitution reaction, the product is an alkylated carbonyl compound in general. The product of the aldol reaction, of course, is characteristically beta hydroxy carbonyl compound. The product of the Claisen reaction is 1,3 dicarbonyl compound. The product of Michael addition or conjugate addition or 1,4 addition is 1,5 dicarbonyl compound. Enolates are very versatile reactive intermediates which can react with a wide range of electrophiles to give all kinds of products with very distinct and very unique structural features.